Okay, so you're going to see that you have two documents at the moment. The one document is a theory booklet. In that booklet, you're going to see, I've tried to summarize basically all of the things you need to know for physics. And then one of each document over there. Oh, you already have, okay. And then you're going to see there's also question papers. There are 3 question papers that I've attached. It's the Gauteng 2022 prelim exam. Behind that, you're going to see a Western Cape paper, and then behind that one, you're going to see a Northwest question paper. Now, they're all prelim exams since we are starting to prepare for the prelims, and of course, we're not going to manage to work through everything, but that means you'll be able to work through it by yourself, and tomorrow, I will give you guys the memos so that you can actually see if you're on the right track. Okay, now guys, we are not going to manage to go through all of the physics content. Hello, please take one of each document. Okay, we're not going to manage to go through all of the physics content in 4 hours. We have 2 hours today, 2 hours tomorrow for physics. It is really not a lot of time. So instead of focusing on covering all of the theory, covering all of the work, our focus is on how to answer questions in such a way that you can get full marks. Because I know a lot of the time you guys study very, very hard. You know your stuff, but then you write your exam and for some reason you don't get full marks for different sections. So we need to understand how they ask questions and how to answer in such a way that we're going to get full marks. Okay. Now, on the first page of the summary booklet, you're going to see it speaks of, well, what you can expect in your exam. Okay, so we're going to quickly go through this. I'm sure a lot of you have seen it before, but just bear with me. Okay, number 1, you're going to see the weighting of the cognitive levels, right? So you might have heard in class, your teacher refers to cognitive level 1, 2, 3, and 4 questions, and so on and so forth. Grade 12s. Cognitive levels do not refer necessarily to the difficulty of the problem. So level 3 does not necessarily mean that it's more challenging than level 2. The levels are about how you think of the different questions. Okay, so firstly, when you write your paper 1 exam, 15% of that paper is going to require you to recall and remember. And what we normally ask you to recall and remember, it's the definitions. Okay, so where do we learn the definitions from? Exam guidelines. Guys, if any of you do not know what I'm referring to when I speak of the exam guidelines, after this lesson you come to me and I'm going to show you where to find them. I know you know your theory. I know you understand the definitions, but the thing is, if you state definitions in your own words, there's a chance you're going to lose or leave out terms. Things like an isolated system, which you always leave out. Things like the term work, which needs to be there, or the temperature, so on and so forth. So you're going to please learn for me all definitions off by heart from your exam guidelines, because that is 15% of your paper. Then we have level 2, which is understanding and comprehension. And what I have found is, because my learners love mathematics, most of them despise physical science, and it might be the same for some of you, but most of my learners, you can come inside, most of my learners really, really like mathematics. They find calculations easier than explanations. Okay, so for learners who are in my class, I would say to them, if you're looking for an 80% or 70%, or you're looking to improve your marks, one of each document, then this is the area where you need to focus. If ever they ask you to explain something, if they say state the reason, if they say to you this light bulb is shining brighter than that one, what is the reason? Those questions that you guys tend to struggle with, those are your level 2 questions, and that is 35% of your paper. So please, grade 12s, don't only focus on calculations, one of each. Don't only focus on calculations, make sure you know how to explain yourself in words as well. And this will probably be the focus when we work through some of the questions. Okay, then we have level 3, which I've said to you is normally your calculations. You get easy calculations and you get difficult calculations. Don't just study the easy calculations. Make sure you know the more difficult ones, because that is 40% of your paper. And then you have level 4, evaluation and synthesis. Guys, level 4 is not the difference between a 70 and 80%. Level 4 is the difference between an 80% and 90%, okay? So if you are battling to get your 80%, you're going to make sure that you know level 1, 2, and 3, and especially level 2, because that's where you guys go wrong in your physics paper, okay? But level 4, if you want to get better and better at level 4, those are those questions that are really new, that you're seeing for the first time in your exam, you're going to try to do as many past papers as possible. But quality over quantity. I have learners who come to me at the end when they're done writing the exam and they say, but ma'am, I did 15 past papers and I got everything right and so on and so forth, right? And then they do very, very badly in the exam. One of two reasons: they're not marking strictly enough, so when they're done trying the paper, they don't go back and mark. You must not be lenient with yourself when you're marking. But they emphasize quantity over quality. If you do the first paper and you get something wrong in it, grade 12s, you don't move on until you understand that one thing. Because that is a misconception that you are going to apply incorrectly in the next paper and the next one and the next one. And remember, the more you practice something incorrectly, the greater the chance that your brain is going to remember it. Okay, so you don't want to practice something incorrectly because then it's difficult to fix that. Okay, so those are the different weightings. In your paper 1 exam, the topics are split up. We have mechanics, wave, sound and light, electricity and magnetism, and matter and materials. Guys, the biggest section is the mechanics section. 65 out of 150 marks, which is approximately 43% of your paper. So if you are someone who does not like work, energy, and power, if you don't like things like vertical projectile motion, if you don't like momentum and impulse, and the famous Newton's laws, you are going to have to deal with that, because that's about 40% of your paper 1 exam. Also, guys, if you do not like electric circuits, if you don't like electrostatics, if you don't like that section that has to deal with electricity, that is about 37% of your paper. So you need to get that right. Smaller things like the Doppler effect is about 10% of your paper. Things like the photoelectric effect, which I think most of you have not covered yet, that is about 10% of your paper. They are normally easier marks than the rest, but you can't neglect mechanics and electricity. Okay, so you're going to see at the bottom of the page, I've expanded on everything for you. You can read through that yourself and make sure that you cover every single one of these concepts when you're studying for your exam. Guys, are there any questions? Am I talking too quickly? So we're fine. Okay, great. All right, now, all of you have seen this page before, I hope. It is the instructions page. Grade 12s, last year I was marking exams. And I'm telling you guys now, most learners do, it's not in your paper, I'm so sorry, I didn't insert it. Okay, most learners don't follow the instructions. Guys, the instructions are not there for you. The instructions are there for the marker. It's not your teacher who knows you and understands you and loves and appreciates you that is going to be marking your exam. A stranger who is now on their 1000th paper and is tired is going to be marking your exam, okay? And you need to write your exam in a way that makes it easy for that tired, miserable person. I'm talking about myself here because I was very miserable, okay? You need to make it easy for that person to mark your exam. First thing that I see all of my learners, and I explain this to them from grade 10. In grade 12, they still mess up, okay? The first thing, bullet point number 3 and number 5. Okay, it is, start each question on a new page. My learners then say, but ma'am, isn't it a waste of paper? Guys, I know we care about the environment and we want to save the trees, okay? But first you want to save your marks, okay? So, when you get to question number 1, multiple choice, your favorite, okay? Because you think it's so easy and then whoops, all the marks are gone, okay? When you get to question number 1, some people like to leave it for last, okay? If you're one of those people, it's fine. But please never leave question number 1 unanswered. Okay, now the stats will say I'm wrong, because I am wrong, but if there are only 4 answers and you guess, you technically have plus or minus a 25% chance of getting the answer correct. So never, ever, ever leave multiple choice unanswered. Also, never spend too much time on it. But if you get into your exam and you want to leave it for last, what you're going to do is you're going to write down your heading, question number 1. You're going to write down 1.1, skip a line, because question 5 says leave 1 line between sub-questions. And then you're going to go on to question 1.2 and you're going to leave a line, 1.3, so on and so forth, until question 1.10. Then you're going to see, oh, there's all this space that is still left on my page. You are not there and then going to start question 2. On the next open page, you are going to begin with question number 2, okay? It makes it easier for us to add up your marks correctly. It just makes the life of the marker easier. And when you are writing your exam, you need to make it easy for us, the strangers, to mark your exam. Are we okay, guys? Okay. Another thing or another problem is this over here: show all formulae and substitutions in all calculations. And number 9, round off your final answer, numerical answers, to a minimum of 2 decimal places. Okay, now you know, I'm hoping, that you need to write down a formula from your formula sheet. Your textbook has different ways of expanding on the different formulae. But when you are answering a question, you begin by writing down a formula from your formula sheet. So on that note, guys, make sure you understand your formula sheet, all right? When I wrote my matric paper, I had a formula sheet and I made all of my notes around it, so that when I went into my final exam, I remembered the things that I wrote down around the different formulae, and I was able to use that to write my paper. So make sure you know your formula sheet. Make sure you know what is there and what is not there. Make sure you know how to get what is not there onto your formula sheet, okay? But you're going to start off by writing down a formula from your formula sheet. You only get a formula mark if you substitute into the formula. Okay, hear me out. If you are doing, for example, electric circuits, and you start off by writing V equals IR, and then you realize, oops, I have no clue what to do next, and you leave it like that, you will not get your formula mark, okay? To get your formula mark, you must at minimum substitute numbers from the question into the formula. Even if you do so incorrectly, it's fine, but only if you make a substitution can I award you a formula mark, okay? Does that make sense? Okay. The next one, round off your final answer. We only round off final answers. Guys, I know it feels like I'm wasting time and we want to get to the physics content, but if you round off in between in one question, you're going to lose marks. You're going to be penalized for rounding off in between. So let's say we are busy with question 2.1. And to answer question 2.1, we're going to make use of the Ohm's law formula. We're going to solve for current, for example, and then we're going to use this in the power formula, which I hope I am writing down correctly, in order to get a final answer to question 2.1. What you're going to do is you are going to sub values into this formula, and you're going to get an answer. You do not, I repeat, you do not round that off. It is not your final answer. If you are feeling a little bit lazy, keep a minimum of 5 decimal places, okay? But otherwise, you write down everything that is on your calculator, okay? You're then going to take that unrounded, I don't know if that's a word, you're going to take the answer that is not rounded off, you're going to substitute it in there, and only when you get to the end are you going to round off to 2 decimal places. Now, some learners find this confusing. They then say, how about if I then go on to question 2.2 and I need to use this answer? Do I use the rounded off one? Do I use the one that's not rounded off? Guys, you use the rounded off answer as you've written it down over there. Okay, are there any questions? please, I beg you, make sure that you follow the instructions. It's very, very easy ways, or let's put it this way, if you don't follow them, it's very, very easy to lose marks unnecessarily. Okay. Now, I inserted this. It's a document that I created many years ago when I joined a new school. Now, the school is a sports school, and what I found was my grade 10s didn't have a good background in science. So when I started to explain the scientific method and so on, I needed to put it into context for them. So you're going to see I make examples relating to sports. You will never get anything of the sort, but I'm going to emphasize and explain to you how to answer questions involving the scientific method, because normally there's at least one in your paper 1 exam and one in your paper 2 exam. Okay. Now, I apologize if this is insensitive in any way. I'm not going to say how, but if it is, my sincerest apologies. Firstly, you know that in an exam you can be asked to write down any of the following. They can ask you to write down an aim, an investigative question, a hypothesis. Normally we don't ask for method or anything of that sort, but then we also have a conclusion. Okay, and this was actually a mistake. It shouldn't say number 8 there. These are examples for the conclusion. So what I did was, when my learners came into my grade 10 class, I said to them, well, you guys do sports and a lot of you are long distance athletes, all right? So what if I as a teacher would like to perform an experiment, and I would like to see from grade 10 to grade 12, as learners age, what happens to the time they take to complete a race? Let's say that's what I want to check, okay? Given that I want to do this experiment and see if you get older and go to matric, do you get faster, right? There were certain limits that I had to place on the investigation. For example, I have boys and girls in my class, right? And you would know historically, we run races separately. We would not put a boy sprinter next to a female sprinter, okay? Also, if I have a grade 10 learner and a grade 12 learner, and I make the grade 12 learner run a 1 kilometer race, and I make the grade 10 learner run a 12 kilometer race, naturally, because the distance of the races are different, one will take longer than the other. Okay, so those parameters that we need to control, those are the controlled variables. We are changing the ages of the learners to see how much time they take to complete the race. So in this case, the aim for this investigation I was speaking about to my grade 10s is stated as follows. The aim is to investigate the relationship between the age of female athletes and the time taken to complete a 12-kilometer race. Now, what point am I coming to here? Well, if ever they ask you to write down an aim, investigative question, hypothesis, or conclusion, then your variables are very, very important. Number one, in physics, we always speak about the relationship, okay? Direct proportion, inverse proportion, so on and so forth. So what are we investigating? A relationship, okay? Between my independent variable, I'm going to use a 16-year-old, 17-year-old, and 18-year-old, and the time, the dependent variable. See, I've mentioned independent and dependent variable. Then I have also mentioned my controls. For this investigation, I'm going to focus on female athletes, and they are all going to run a 12-kilometer race. I've mentioned my controls. If an investigative question, a hypothesis, aim, or conclusion is out of 3 marks, it means we are looking for independent and dependent variable, 1 mark. The relationship, 2nd mark, and then controls, mentioning your controls, that is going to be your 3rd mark. Don't leave them out, these are 3 marks, okay? Now, very often they ask you to write down an investigative question. The thing with the question is, it may not be answered with the words yes or no. Okay, so listen to this statement. Do older athletes take more time to complete a race? Do. The answer would be yes or no. meaning the question is wrong, it's not scientific. Okay. We never ask questions that can be answered with yes or no. We instead always question the relationship. So grade 12, you are going to remember this. Whenever you ask an investigative question, you're going to start with, what is the relationship between independent, dependent variable controls? Okay, but always, what is the relationship? Because how do we answer this? They're directly proportional, inversely proportional, as the one increases, the other, so on and so forth. Okay, please go through this. I'm not going to go through all of it. Conclusions, guys, please just make sure you don't say I believe, or we have come to the conclusion, or I think that, or anything of that sort, or even for your hypothesis. You make it just a statement, a clean statement with independent, dependent, and controlled variables. All right. Now, just quickly, I want to speak about the variables. We say the independent variable is what you as a scientist are going to change. The dependent variable is dependent on what you are changing. It's dependent on the independent variable, and that is what you are going to measure. Okay. Now, in an exam, you might be asked to plot a graph for these values. Okay, and the question becomes, where does the independent variable go and where does the dependent variable go? When I was in grade 9, my natural science teacher taught it to me this way. She said, there is a thin stick and there's a very big, heavy stone. Okay? Now what happens is it's a very windy day and one of the two is going to fall over. What do you think is going to fall over, the stick or the stone? The stick. Therefore, the independent variable goes onto the x-axis, while the dependent variable is going to go onto the y-axis. The dependent variable, the stone, stays standing. The independent variable is going to fall over. Are there any questions? Okay, let's quickly move on. On the next page, you're going to see the term fairness. I saw this, if any of you are from Gauteng and you wrote the provincial exam, they asked a question about fairness. If we ask whether a test is fair or not, the question is only the independent variable changing? So for example, in that question that I had right at the start, the aim of that is, investigation, if I am going to use both male and female athletes and I'm going to change their ages, the test is not fair. Okay, so to answer whether the test is fair or not, you see how many independent variables do I have. If I only have one independent variable, then and only then is the test fair. The term reliable means can we rely on the results. And in science, we can rely on the results if we test it more than 3 times and we always get the same result. These are just terms that you're going to have to know. Okay, we are almost done with this section. Tables and graphs. I'm not going to go through everything. All I want to point out to you guys is this. You see, for the Gauteng paper that some of you wrote recently, you had a question that looked like this. Okay, this was a section on electrostatics. Is it familiar to any of you? Okay, now, they asked later on for you to calculate the gradient. And when they were done with that, they asked you to do a calculation. Be very careful. If we pay attention to the units, the force, which in this case is the dependent variable, the stone is standing up, okay? The force is measured in newtons. Is newtons the correct SI unit for force? Yes, it is. I hope you guys know it from grade 11, okay? Now look at the charge. What is the charge measured in? Nanocoulombs. Here it is measured in nanocoulombs. So what does that mean, grade 12? It means if you take a piece of data from the x-axis, this 30 is not 30 coulombs. It is 30 nanocoulomb. And before you perform a calculation, you need to convert. So please pay attention to the units of measurement that are given to you in your tables and on your graphs. Otherwise, you're going to lose marks unnecessarily. Are there any questions? Okay. The very, very last thing that I'm going to speak about is direct and inverse proportion. We don't have a thing like indirect proportion. I hope you guys know that. Guys, direct proportion speaks about a straight line. We all know y equals mx plus c, but it's a straight line that is increasing and it must pass through the origin. Okay? When the one thing is 0, the other thing must be 0. Otherwise, it is not direct proportion. So looking at this graph over here we have direct proportion. But what if we had another line and it started over there? Sorry, it's a very bad line, but it started over there. This here, grade 12s, is not direct proportion. They are linearly related, but it is not direct proportion, because direct proportion says it must pass through the origin. Please be very careful. Don't be careless with words like direct and inverse proportion. Direct proportion is where we have a line, y equals mx plus c, but the c value, the y-intercept, what is it going to be equal to? 0. The c value is 0, so we just have y equals mx. Okay, when you get to electric circuits, in that section you're going to be making use of this very often. Okay, inverse proportion we know as the one thing increases, the other is going to decrease. Over here we are speaking of a hyperbole, so it's a hyperbolic function. As you can see, it curves like that. Now guys, I know that you have been dealing with Newton's laws for a very, very, very long time, okay? But there are still some cases where some of you get it wrong, okay? So what I'm going to attempt to do, I'm going to try my best, is going to be to summarize what is on this page. These definitions that you are seeing, guys, I think I said this already, is from your exam guidelines. You can learn them exactly as they are. So this is Newton's laws all summarized onto one page, okay? The formulae, however, you must just check. Some of them are given, some of them are not given. I want you guys, before I go on, to go to the exam pack. So the exam pack is this one. Okay, mine looks a little bit different from yours, but it's the other one. Okay. As I said, you have different papers there, and I want you guys to do a bit of the multiple choice. It's going to be quick, it should be easy. So you're going to go to the Gauteng paper, you're going to do question 1.1. The paper behind that, you're going to be 1.1 and 1.2. And if I'm not mistaken, yes, also 1.3. Okay, so first paper 1.1, second paper 1.1 to 1.3. And then for the last paper, you are only going to do question 1.1 for me. Okay, I'm going to give you guys 5 minutes and then we're going to continue. Okay, so you guys should be more or less done. Okay, if this happens to you in an exam and you are not done, you're going to quickly go and guess so that at least you have a chance of getting it right. Okay, so I'm going to, before we look at the answers, sort of summarize Newton's laws and help you guys to discover where you're going wrong. Okay, now you've been dealing with these since grade 11, but that means one of two things. You either mastered Newton's laws or you gave up on it and you've still given up on it. Okay, but Newton's laws is very important because you need to understand it in order to understand work, energy, and power, which I know a lot of you love very, very much, right? Okay. So let's start off with the different forces. You know of weight. It's one of the first forces you guys studied. Can you still hear me properly when I turn my head? Okay, it's one of the first forces you studied. We know that when we are dealing with an object on the surface of the earth, we can calculate the weight by saying Fg equals mg, where g is the gravitational acceleration on the surface of the earth. It's given as 9,8, and you guys know this. Okay, but how about when we go to another planet, as I've seen in one of these papers, I think it's the Western Cape paper. if you go to another planet or you go to the moon, for example, on different planets, on different places or in different places in our universe, you're going to see that G is going to change. So how do you calculate it? You calculate it using what you learned in grade 11, and that is G equals the gravitational constant. It's on your formula sheet. Guys, your formula sheet is right at the back of the summary booklet, okay, if you're looking for it. So it's G multiplied by the mass of that planet divided by r squared, where r is the radius of the planet. Year after year after year, what happens in this section is you guys leave out the square. Okay, you're so nervous, you're in such a big rush that you leave out the square. Please be very careful. And another thing, grade 12s, about 3 of my learners who wrote my paper this past term had their calculators on the wrong settings. That meant that all of their answers were incorrect. So when you get into your paper, please make sure that your calculator is on the right settings, or it's going to mess everything up for you. Okay. Normal force, you need to be able to define. We say that the normal force is the force or component which a surface exerts on an object and which is perpendicular to the surface. Yes? It's the one, so the most important thing is that right at the top of your calculator, you should see a D. If it's a G or an R, that means that we are measuring angles in a different unit. So there we're dealing with radians, and I don't even know what G stands for. Okay, so please be careful. All right, if you see that you are getting answers while you are practicing that are not like the memo, then you must check your calculator. Okay. Now, normal force. Guys, is the normal force equal and always equal to the gravitational force? No, we know that, okay? And I'm hoping that you know how to calculate it. Should I show you guys? Are we scared to say yes? I don't see any no's, so I should. Okay. There are 3 cases, and guys, in matric, we expect you to know these cases. It's very, very rare that you're going to have a problem in your paper where you have a box on a flat surface and there's no forces at an angle acting on that box. Okay, it's very, very rare. So you need to know how to deal with forces at an angle. Okay, so firstly, we can have our surface. Let's just move this. Okay, let's try that again. Okay. So there's our surface, and what we can do is we can go and put a box on that surface. Okay, at the moment as this box stands, we can say, okay, acting on this box is going to be a normal force, which is going to be upwards. By the way, when you draw your free body diagrams, we never ask you to draw force diagrams, but for free body diagrams, please don't use pencil. I know that some of your teachers allow you to use pencil and they do mark it, but sometimes the pencil fades by the time we have to mark the final exams. So rather use pen to draw your arrows and to label. Okay, so here we know we have the normal force and we also have a downwards FG. But then what I can do is I can say to you, this box is being pulled at an angle. So there's an additional force, and we're going to call this force F. If in the exam they call it F, you stick to F. You don't change it to FA, okay? You stick to F. So here is that. I tell you this force is at an angle, and that angle is called theta. The normal force is the force, if I'm looking at this box, it's the force that this table is exerting on this box. So if I take my finger and I pull this box up slightly, what's going to happen is that the table will no longer push upwards on the box as much as it was in the first place. And that means the normal force is not always going to equal to Fg. So step number 1, what we're going to have to do is we're going to have to break this force at an angle into components. We always deal with an x and y axis, so there's x and y, and we see over here that this force is not in x or y, it's somewhere in between, okay? So we're going to break it up into its components, and I'm going to draw them as solid lines because this is my rough work, all right? So we go and we draw in fx, there's our fx, and acting upwards we have fy, okay? From this, we can go to a free body diagram. Very, very, very important. When you are drawing free body diagrams in your exam, you may not include the resultant with its components, even if you use dotted lines for the components. I'm going to say that again. You may not draw the resultant with its components, even if you use dotted lines for the components. You're going to lose 1 mark, all right? So if I draw this free body diagram, not to scale, and of course you guys will make use of a ruler. We're going to have the normal force, we're going to have the downwards Fg, and I'm going to choose to use the components of this applied force. So please don't go and draw the components in at an angle because you've run out of space. If your circle is too small, go and make the circle bigger. Okay, like that. And then what we're going to do is we're going to draw in Fy. There's Fy, and over here we have Fx. We're assuming here that the surface is frictionless, for example. Now in this case, what we have is there are 2 upwards forces and 1 downwards force. And this box is not moving up or down. So if it is not moving up or down, it means the box is at rest in the y direction. According to Newton's first law, what does that say about the net force? It's 0. The net force in the y direction is 0, and that basically means that this force plus that force is going to equal to that one. We can therefore say for this case, where we have an upwards force at an angle, that we're going to have that the normal force, and I'm going to write it out the first way and then get to the other way, plus Fy is going to equal to Fg. So solving for the normal force, in this case, the normal force is not equal to Fg, it's equal to Fg minus Fy. Okay, be careful. Now what if we change the angle, or what if we change the force? And instead of making the force act upwards at an angle, we now make the force act downwards at an angle. Okay. If that is the case, so if we have this, guys, if I go too fast, please slow me down. Oops. If we have something like this, then the components are drawn differently. We're going to have the downwards y component over there, and the x component is going to be towards the left. So in this case, what we have is that this is one of the y forces. We also have this one as the other y force. And what is my other y force? Fy. Okay, we can go and draw a free body diagram. I'm going to skip it because we're going to run out of time. And in this case, where we have a downwards pushing force at an angle, think about it. I'm pushing onto the box. So if I push onto the box, the table pushes more onto it. And what we have is that when we have a force at an angle downwards, in that case, the normal force is going to be Fg plus Fy. Okay, the normal force once again is not equal to Fg. Are there any questions, guys? Okay, the last scenario is the case where we have an object that is on an incline. Okay, so over here, this that I showed you, that is where we have an upwards pulling force. This is a downwards pushing force, but sometimes you're going to have an object on an incline. When we have an object on an incline, is the normal force equal to Fg? No, it is not. Okay, the reason is because, guys, Fg is always straight down. Okay, this is what my lecturer said to me. She said her teacher or her lecturer or something of that sort, it was a long time ago, so I don't remember the story correctly, was very, very frustrated. And what he did was, he said to the learners, Fg always goes straight down. Then what he did was, he spat on the board. And guess where the spit ran? Down. Okay, so Fg always goes straight down. Okay, so in this case over here, Fg is going to be straight down. Normal force is perpendicular to the surface. So the normal force is going to be at a 90-degree angle to the surface. There's my normal force. And as you can clearly see, they are not parallel to each other. So what are we going to have to do? We're going to have to take Fg and break it up into its components. It's going to have a perpendicular component and a parallel component. And when you complete the triangle, and I give you the angle of the incline, it's important that you know how to complete the triangle. So first, we're going to start off with the perpendicular component of Fg. Fg perpendicular. We call it Fg perpendicular grade 12s because it is perpendicular to the surface. It forms a 90-degree angle to the surface, and you start by drawing that one. Then I see my learners do this, and this is very, very, very wrong. They then say there is Fg parallel. If you just think about this very, very nicely, guys, let's say that I'm walking down the stairs, and the stairs of course at an angle. Do you ever slip up the stairs? No, you slip down the stairs. And why? Because of Fg parallel. So how are you going to know that you've drawn the components correctly? They're going to be correct if your Fg parallel goes down the incline. It is the component of the gravitational force that makes you slip. Okay? Fg parallel is not your friend. Are we okay? We know that the angle of the incline, and we can use simple geometry in order to prove this, alternate angles, cointerior, supplementary, so on, to show that this angle is equal to that angle. Alright, but I'm not going to show you that because it's unnecessary. So based on the fact that over here we have a right-angled triangle, we can clearly see this is the hypotenuse. This side, Fg parallel, is opposite the angle, and this side, Fg perpendicular, is adjacent to it. Okay, so if I say to you, please go and calculate Fg perpendicular, you're going to say the hypotenuse, Fg, multiplied by its next to the angle. Next to means cos theta. Okay, for Fg parallel, it is opposite the angle. Guys, if you can't hear me, please tell me. It's opposite the angle. Opposite means sine. So this is going to equal to Fg sine theta. And if we want to expand this even further, then this is going to be mg cos theta, mg sine theta. Okay. So in this case, where we have an object on an incline, what happens is that our Cartesian plane is tilted. Now our Cartesian plane doesn't look like that. It now looks like this, with an x-axis and a y-axis. Ignoring Fg perpendicular, which force is parallel and opposite to the normal force? Fg perpendicular. This one and that one are equal to each other. So when we are on an incline, the normal force is not equal to Fg. No, it's not even parallel to Fg. When we are on an incline, the normal force is equal to Fg perpendicular, which we can expand as Fg times cos theta, or we can say the mass times the gravitational acceleration times cos theta. And those are the three different cases that you will find, of many, where the normal force is not equal to Fg. So please be very careful. Are there any questions, guys? It's the small things, okay? If you're going to get an 80% or 90%, it's about the things that frustrate you and taking time to get over those hills. Okay. Now, frictional force. This got my grade 12s nicely last year in their prelim exam. Frictional force is only dependent on two things. Okay, but before we get to that, let's speak about the definitions. We say frictional force is the force that opposes the motion of an object and acts parallel to the surface. Guys, friction force is not opposite to the applied force. Let's think, I'm on an inclined plane and my box, which is very heavy, is going downwards, and I'm trying to keep it up, but it's pulling me down. In which direction is my applied force? I'm trying to keep it up. My applied force is that way. In which direction is my box moving? Down. It's too heavy. I'm just not strong enough. I'm going to have to go to the gym, okay? So it's going down. My applied force is up. Friction force is not in the opposite direction to applied force. My force is this way. Friction force is in the opposite direction to the motion. So if the object is going down, in which direction is my friction force? Up. Be very careful, okay? Year after year, I see the friction force is in the opposite direction to the applied force. Be careful, okay? We get two types of friction. We have static friction and kinetic friction. You guys will go through the definitions. I hope you know the difference between the two. But I want to come to this. I copied this from your exam guidelines, but now I notice there's something missing. Friction is dependent on only two things. Only two things. And we can see that from the formulae. Look, both of these formulae look similar. We say that friction is equal to a coefficient multiplied by the normal force. Okay, so number one, grade 12s, we can see if the normal force is big, if I push onto this and push it, I'm going to not only break things, but I'm going to increase the friction force. If you push down on it and push, you're going to increase the friction force, because friction mathematically is directly proportional to the normal force. Okay, then we have this magical thing over there. What is that about? Physically, literally speaking, what is that coefficient about? Yes, the nature of the surfaces. Okay, friction depends on the normal force, and although it's not here, it depends on the types of surfaces. Am I rubbing silk on wool? Am I rubbing silk on wood? Am I rubbing silk on a gravel surface? Okay, that is going to change the friction force, the types of surfaces that are interacting. And those are the only two things that friction depends on. Grade 12's friction does not care about surface area. Okay, it does not care about how fast the object is moving. Of course, when we go from at rest to motion, then we go from static to kinetic friction. But once we are dealing with kinetic friction, that kinetic friction is constant, even if we push the object faster. Okay, so please, those are the two things that friction depends on. The coefficient, which is about the types of surfaces, and the normal force, which you guys have now seen, is dependent on any y force acting on the object. Because if we have a force at an angle, the normal force will change. If the object is heavier, the gravitational force will change, and therefore the normal force. Okay, so that is friction. Newton's first law, second law, third law, you guys know this. I'm sorry if I'm boring you to death. Just stay with me a little bit longer, okay? Newton's first law says a body will remain in its state of rest, and this is where my learners end. They say rest unless a non-zero or resultant force acts on it. Guys, if you leave out constant velocity, you're going to lose a mark, okay? So whether an object is at rest or moving at a constant velocity, F net is equal to 0. So you must watch out for keywords like constant velocity. It immediately implies F net is going to be 0. Newton's second law is very, very long, but how are you going to remember it word for word? You're going to learn how to manipulate the formula. See, if we divide both sides by mass, and make A the subject of the formula, we get acceleration is equal to F net over mass. Basically what this law says is when the net force increases, acceleration will increase. when the mass which is in the denominator increases. When the denominator increases, the whole fraction becomes smaller, and therefore acceleration is going to decrease. We have inverse and direct proportion, which you can actually find in this formula. And if ever you are using this formula, you start off by copying it as it is from your formula sheet, please. Okay. Newton's third law is a big, big problem, okay? And I'm going to get to this in the multiple choice section. We're going to see if you guys went right or very, very wrong. But Newton's third law force pairs cannot cancel each other out. So here I have an object on a surface. Please imagine the surface. I'm too lazy to draw it. And we have an upwards normal force and a downwards Fg. My learners, shame, my poor learners, they're actually wonderful, I love them. But my learners will tell me that the normal force forms a Newton third law force pair with Fg. This is wrong. Newton's third law force pairs act on two separate objects, okay? They cannot act on the same body. So in this case, we can say the normal force and Fg are balanced, but they are not Newton third law force pairs, okay? And then lastly, we have Newton's law of universal gravitation, which is linked to this section over there at the top. I'm not going to spend a lot of time on this. I'm going to give you guys an exercise where you can go through it. When you go through past papers, if you love past papers, you may find that there's not a lot of questions on this in those past papers. That does not mean you neglect it, because my dear grade 12s, you guys might be the lucky ones, okay? So you make sure that you learn Newton's law of universal gravitation, okay? You make sure you know how to apply it. Now, a big problem in this section is I give you two bodies, a small little planet and a very big one. And I tell you the two planets are applying forces on each other, specifically gravitational forces, which you guys know exist because both bodies have mass. Then I say to you, you see this planet, let's call it planet B, and let's call this one A. And I ask you, does planet B exert a stronger force on A than A exerts on B? And most of my learners, shame my poor learners, will say yes. Okay, that's not true. These are Newton's third law force pairs, which means even though this body is smaller, the force it experiences is equal but opposite in direction to the pulling force that it exerts on this object. A lot of people struggle with this. So I say to you guys, here's my sheet of paper. And I'm telling you guys, if I leave this, then the earth is pulling down on the sheet of paper. But guess what? The sheet of paper is also pulling up on the earth. Okay, that's what Newton's law of universal gravity says. But then my learners say, but ma'am, the paper went down and I didn't see the earth jump up. Okay, so this is what I say to them. I say, well, here's a little eraser. You know that eraser when you get into the exams and you forgot your eraser, so you ask your friend to cut you a piece. You know that tiny little one? There's my eraser, okay? And then over here I have a giant truck with the handbrake up so it can't move. So what I'm going to do is I'm going to take my finger and I'm going to push against this eraser with a certain force. The eraser will probably move. I'm sure I'm strong enough to get it to move. Then what I do is I take the same force and I apply it on the giant truck. Is the truck going to move? No. But is the force the same? Yes, it is. Okay, so don't use effects as a way of determining whether the forces are equal or opposite. Newton's third law says they are equal and opposite. The effects are as a result of their size and so on and so forth. Okay. So now that you guys are done listening to my speech, let's see if you guys answered these questions correctly. Okay, question number 1.1 says, which of the following best illustrates balanced forces? Guys, Newton's third law force pairs cannot balance each other. They are acting on different bodies. So if any of you said D, it's wrong. The correct answer here is C. Okay, if we have a stationary object, it means the forces are balanced. Okay, this would also apply if we have objects moving at a constant velocity. But in this case, the only case where we have balanced forces is stationary body, upwards normal force equal to downwards Fg, and they are equal but opposite to each other, so they are balanced. Okay. Newton's third law force pairs are not balanced forces. They act on different bodies. Be very careful. Okay? 1.1, they say a car is moving at a constant velocity. Now, before we go on, we identify a key word. Constant velocity means the net force is 0. There you go. And if you knew this, then you would know the correct answer is D. Okay. If there are any questions as I go along, you guys let me know, okay? Question 1.2. They say the force diagram below shows the forces acting on a box. I showed you guys how to work this out, okay? So what is happening here is this is a Y force, that's a Y force, and I know, sorry, it didn't print so well. Do you guys know of Stanmore physics? If you don't know, you go onto that website and you go and make use of all of their past papers, please, okay? But over here, we know there's one more Y force. It's the downwards Y component. And of course, there's also going to be an X component. So in this case, the normal force is going to be equal to this plus that. You can draw a free body diagram so it makes a little bit more sense. But the correct answer is this one that you can't see very clearly. So if you didn't manage, I understand it was the printing, that wasn't you. Okay, so the correct answer is B. It's going to be, excuse me, Fy plus Fg. That's covered is F sine theta. Okay, it's F sine theta. Okay, question 1.3, they say an object mass m2 attracts another object mass m1 with a force F. If the mass m2 is doubled, the force m2 exerts on m1 will be. Firstly, what type of force are we dealing with here? Gravitational force. These are forces that two bodies are exerting on each other because they have mass. So we know the formula we are working with is Fg equals, or just F, it depends on how you write it, G m1 m2 over r squared. Okay. When you learned about this, when you learned how to define Newton's law of universal gravitation, you learned that Fg, the gravitational force, is directly proportional to the product of the masses of the two bodies. And you also learned that Fg is inversely proportional to the square of the distance between their centers. Be careful with that centers thing. Sometimes we give you the surface above the distance or the height above Earth. Be careful. Okay, but anyway, over here what they are changing is mass. So this is what I do. You may have your own unique way of working this out. I go to this and I say, the mass of m1 is going to stay the same. So in the place of m1, I put a 1. The mass of m2 is going to be doubled, meaning times 2. So in the place of m2, I put a 2. And in the end, the answer I get is 2, which implies that doubling one of the masses leads to Fg being 2 times what it was. And therefore, the correct answer is C. Okay. 1.3. This 1.1. This is your Newton's third law problem. Okay. Remember my big truck and my little eraser that I borrowed from a friend. Okay. In this case, here is my little car, and here is my huge truck. All right. And they say, in this case, the car and the truck has a mass 3m, the car has a mass m, and what is going to happen is they're going to collide. And when they collide, the car is going to exert a force on the truck, and the truck is going to exert a force on the car. These forces are exerted simultaneously, right? Object A is exerting a force on object B. So Newton's third law says, therefore object B will exert an equal but opposite force on object A. So grade 12, the correct answer here is A. Okay. Multiple choice is the best way of identifying your misconceptions. If you are wondering why you are going wrong in the longer questions, multiple choice might be able to tell you what the problem is. But what you guys must not do is answer multiple choice question, get it wrong, and leave it. You take a photo of that and you send it to a friend. That person in class that is getting 90%, you ask them, you humble yourself and you say, what is this and why is it like this, okay? You go to your teacher and you bug your teacher so that by the end of the year your teacher says, oh, I'm so glad he or she is leaving, okay? Right? You make sure you never leave a stone unturned, okay? So now I would like to go to a bit of a longer question. Are we still okay? Okay. We have like 50 minutes and then we are done with the session. Okay. This is from the Gauteng paper. It is Newton's laws problems, and I think to save time I'm not going to go over all of it. It's only question 2.3 and the focus is actually on 2.3.2. I think you guys will manage 2.3.1. Okay. I'm focusing on this question because it is a level 2 problem, which my learners would say, some of them, shame my poor learners, is level 4 because I tend to focus on calculations. I love calculations and then my learners are disadvantaged as a result, okay? So in this problem they said, we have block A and we have block B below. They are identical blocks, each with a mass of 5 kilograms. They are joined together by a light inextensible string, blah, blah, blah. We've seen that over and over again. And the blocks are being pulled with a force of 65 newtons. There it is. Can you see grade 12? They labeled this F. You're going to stick to F. You're not going to call it FA or B or G or whatever you feel like in your heart. You're going to label it F, okay? Then they go on and they say it's at an angle of 40 degrees. Immediately you need to remember normal force. My normal force is changing. Ma'am taught me that the normal force is going to change. It's not going to be equal to Fg. And then they say the two blocks accelerate to the right at an acceleration equal to 2,17 meters per second squared, and the tension in the rope is 26 newtons. Now just a note on that tension. If we are looking at block A, we are saying block A, that way, block A is being pulled at 26 newtons and block B is being pulled at 26 newtons. Don't go and divide it by 2. Please don't do that, okay? So the calculation, just a few things I want to point out for the calculation. When you write your final exams, please label your calculations. So if you're doing a calculation for A and then you do a calculation for B, write down A calculation, B calculation. Don't leave me as the marker to assume, because when I'm tired and when I'm on paper number 1125, I don't feel like assuming and I'll probably assume wrong, okay? So you label your calculations. Another thing, guys, is they don't say here draw a free body diagram, but you are going to make sure you do so. You draw a free body diagram for every single thing, every single object you see in a Newton law problem. You don't need to do it on your question paper, or sorry, the answer sheet. If you're scared the marker's going to mark it, do it on your question paper. There's always lots of space to do your workings there. But don't go without drawing free body diagrams. Okay. Now I'm going to skip this. You guys will do it in your own time, draw free body diagrams, perform the calculations. I want to go to 2.3.2, which says, explain why the frictional forces on the two blocks differ. If we draw or if we complete this, there's going to be a friction force there and a friction force there. The friction force on A and the friction force on B. I know the friction forces are that way because they told me it accelerates to the right, and friction is in the opposite direction to the motion. So they want you to explain why this and that are not equal for 3 marks. I want you guys to try this. I'm going to give you 3-4 minutes and then we're going to continue. All right, let's quickly look at it. So most of you probably knew the reason why. But the question is, were you able to state it in a way that could get you 3 marks? Okay. Last year when my learners did this in my class, and I only have 12 learners, so it's not a big thing, but of my 12 learners, no one was able to get full marks for this question, okay? And it's not because they don't know their physics. It was because on my side, I didn't teach them how to answer these questions. I hope that your teachers did. Okay, here we are required to explain. So why did I go through the scientific method with you? Was it just to waste your time? No. It's because I need you guys, when it comes to explanations, to think independent variable, dependent, and controlled. Because when you answer a physics question, you need to answer by speaking about these things. Okay. So let's look at the 2 bodies. What I've done is I've drawn 3 body diagrams for them. I saw on block B, unlike on block A, there's an applied force. It's a contact force and it is only acting on block B. Okay, block A will move as a result of it, but it is not it is not working or acting on block A. So this can be broken up into components with an Fy and Fx, as you can see on my diagram, all right? If you draw this and then you also go and draw in F, you're going to lose a mark, even if you draw the purple ones using dotted lines, okay? So you never draw a resultant with its components. So when you look at these 2 bodies and we look at the y forces, you're going to see here we have the normal force and Fg. Here we have the normal force, we have Fg, and there's something else. What is the something else? Fy. And like I told you guys right at the start, that Fy is going to impact the normal force, which is important because friction depends on the normal force. Okay, so what we're going to do is we pull out one of the formulae. Friction is equal to the coefficient multiplied by the normal force, and we are going to answer this question in terms of this. Number 1, looking at the 2 bodies. Okay, object A and object B. By the way, when you answer these questions, you should use bullet points. So don't write a long paragraph, not only because it makes bullet points make it easier for us to mark, but it helps you to order your thoughts. Okay, so number 1, let's speak about constants. Friction is dependent on the coefficient and the normal force. For these 2 bodies, what is kept constant? The coefficient. Remember right at the start they said these are identical bodies. They didn't say that just because they want to confuse you and add information for nothing. Identical means the 2 bodies have the same surfaces. So we're going to start off by saying the surfaces are the same. Sorry about my handwriting. The surfaces are the same for both blocks, and therefore the coefficient, in this case we're dealing with kinetic friction, is the same. If you did not write this down, you lost 1 mark. Okay, you're getting 1 mark for stating your control. The 2 blocks both have a coefficient that is exactly the same. Okay. Number 2, we look at the 2 bodies and we say, what is different? You guys told me, yes.
This is the independent, dependent, controlled. Which one is this one?
This is controlled. Okay, this is your controlled variable. So your controlled variable is the thing that we are keeping constant. Okay, so we've mentioned the control. All right. Now that we are done with that, we look at the 2 bodies and we say, what is different about them? You guys told me block B has a force at an angle and therefore Fy acting on it. And what does that force do? Well, because that force is upwards, we have in this case that the normal force is going to equal to Fg minus Fy. And that means that the normal force is becoming smaller as a result of this y component. So we're going to say block B has Fy acting on it. Therefore, the normal force on B is smaller. Okay, yes.
You mentioned the fact that the force acting on block B is at an angle.
That's fine.
But you didn't say that Fy is acting.
That's okay. Okay, so guys, if you mentioned a force at an angle instead of mentioning Fy, that is okay. Okay, but please make sure you mention that it's at least at an angle. Yes.
And for the second bullet point, is that the independent?
Yes. Okay, so here we are mentioning the independent variable. What is our independent variable? The normal force which is affected by the force at an angle. Now we are going to draw the relationship between independent and dependent variable, and we're going to say, therefore, since Fn on B is smaller, the friction force, I'm using shorthand, you guys must write out full works please. The friction force on B is smaller because, and you guys write this out in words again, not the way I am, friction is directly proportional to the normal force. Okay, so I've mentioned my controlled variable, I've mentioned my independent variable, and I've shown the relationship between the independent and dependent variable. And grade 12, this is what is going to get you 3 marks. Okay, it's not very easy to answer in this way. It requires a lot of thinking, and again, if you're more geared towards the calculations, then this is where you tend to lose your marks. So remember, 35% of your paper is this stuff. Don't neglect it. If you look at past papers, you're going to see the weightings are not the same as they are now. Weightings of past papers normally is a lot more calculation than these things. So look at your more recent papers. The Gauteng papers tend to include a lot of these types of questions. Are there any questions? Okay, yes.
It's not a question, but I couldn't help but notice that the tension was going this way for on block B.
On block, did I make a mistake? I made a mistake. You are right. Is that what you're saying? Yes. Okay guys, I made a big oops here. Thank you so much for that. This tension is not that way. The tension is this way. Okay, please don't draw it the way I have, but yes, the tensions are in opposite directions. I'm so sorry if I caused confusion. Is there anything else? Okay. If there's nothing else, guys, we only have 30 minutes left, so we are almost there. All right. I'd like to now go on to your favorite, work, energy, and power. Okay. Everybody's favorite, always. Okay. All right, guys, work, energy, and power looks difficult. It looks difficult because, and it causes confusion in your brains because it's long, it's a lot. It's not actually that the individual concepts were difficult. You guys found, guys please shush, you guys found that as your teachers were explaining, you understood the first part, and then you understood the second part, and right at the end you understood the third part, and then you got into your exams and everything was together, and now we don't know if we're coming or going. Okay, it's just a lot. And there are lots of equations. So you being able to create relationships between them, that is what's important, and that is what we're going to try to do now. Okay? On this page, I have summarized everything relating to work, energy, and power. Again, the definitions are the ones you need to learn. So don't throw this away. Go and make use of it. All right? Now, before I explain any of this, I want you guys to try again a few multiple choice questions. So here they are. The first, very first paper, the Gauteng paper, you're going to do question 1.5. Okay, first 1.5 of the Gauteng paper. The next one, the Western Cape paper, you're going to do 1.6. And then from the Northwest paper, the last paper, you're going to do 1.5. So it's 1.5, 1.6, 1.5, please. I'm giving you guys 3 minutes. Okay, are we done, guys? All right. So just like previously, I'm going to attempt to summarize, and then we're going to look at the multiple choice answers, okay? We only have like 30 minutes, and then you guys are free to disappear. Okay, so just bear with me for 30 more minutes. Okay. Work, energy, and power. Again, challenging because it's difficult to create connections between the different sections. Okay, firstly, we said work can be calculated by taking the magnitude of the force, very important, the magnitude, multiplied by the magnitude of the displacement times cos theta, where theta is the angle between the force and the displacement. Okay. Work is a scalar quantity. Force is not. So now comes Newton's laws, where you were using vectors, and vectors were very important, and choosing a direction was important. And we come to this section where sometimes, because you might need to calculate the net force, you will need to use directions. But then when you plug it into the equation, you're going to have to forget about directions, okay? That can be very confusing. Now when it comes to this, my advice to you is for work, energy, and power, just like the section on Newton's laws, always begin by drawing a free body diagram, even when you are told otherwise. Okay, a free body diagram is your guide. It's your tool to know that you know what is going on. So let's say that we have a box that is moving on a surface, a horizontal surface. Okay, I tell you it's a rough surface, and this box is being pulled towards the right with an applied force at an angle. Okay, there are other forces acting on this box. Like I said, friction will be in the opposite direction to the motion. There's going to be the upwards normal force perpendicular to the surface, and we are also going to have the downwards Fg. Now when you need to do a calculation to calculate the different works, my advice is start off by drawing a free body diagram, because that is going to help you with that theta angle. Okay, so in this case, here is my force, here is Fn, we have backwards friction, and over here Fg. If this box is moving that way, then it means our displacement is towards the right. To make it easy for yourself to decide on the angle, my suggestion is on your rough work for yourself, not for the marker, please, because you might be penalized. On your rough work, you are going to go and include the displacement, okay? Because that is going to help you decide on the angle. If we are looking for the work done by this force F, we can clearly see from the diagram I have here that the angle between the displacement and that force is theta. So to calculate this, so if it's 40 or 30, we'll plug that in, and we will say it's the magnitude of the force, change in x cos theta. From the same diagram, grade 12, it's very clear that the angle between the displacement and Fn is 90 degrees, okay? And we know that the force that acts at 90 degrees to the displacement does 0 work. So if we are calculating the work done by Fn, we would say the magnitude of Fn change in x cos 90 degrees, which would give us 0 in the end. Okay, and if we are looking at the friction force, you can clearly see friction is all the way to the other side, making it 180 degrees. I suggest you guys do this to help you with those angles, but this is your rough work. Do not include this if they say draw a free body diagram for marks, please. Okay, are we okay? Are there any questions? Yes. 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 180 minus, what do you mean by 180 minus and 180 plus? Okay, let me draw it. Give me 1 second. So you're saying we're on an incline and we have an object like that, right? And then I ask you to do what?
To calculate the angle between the gravitational force.
Okay. Okay, I see the problem. So the issue I think that you have, I don't know if it's the angle, you'll tell me, is the issue the angle, or is your issue the fact that sometimes we use this displacement and other times we use the height? Is that your problem? Okay, I'm going to explain that in 1 second, so just hold that thought. Okay, or maybe I should just speak about it now. Guys, maybe you've seen in past papers, or maybe you've seen when your teacher was explaining that when we have a box on an incline and I say to you, maybe calculate the work done by the force, the applied force, and this object is moving up the incline, then we will say the work done by the force is equal to the force change in x, where we take this displacement, where we take this displacement over here. Let's try that again. We take this displacement to be the change in x, okay? And then we will say cos 0 because it's moving in the same direction as the displacement. But then we do something magical. Then we go on to Fg and we say, to calculate Fg, we are going to say the work done by Fg is equal to Fg multiplied by the height. Okay, so now we use this change in y over there. Okay, and we plug that number in, whatever that number may be. And because it's moving up and Fg is down, we say cos 180 degrees, right? It's moving upwards and Fg is down. That's why it's 180. They are in opposite directions. So, the displacement, the height, is going to be that way, and Fg is going to be downwards, okay? Meaning the angle between the two is 180. That's where I got the 180 from. Are we okay with that? Now the problem that you guys struggle with and that really makes you suffer is, why is it that for Fg I use this, but for this force I used the actual displacement? There's a difference. There's the actual displacement and then there's the height. The reason why it was okay for us to use this for Fg is because Fg is a special type of force. If you go down to the left, bottom left of your page, you're going to see over here I discuss conservative and non-conservative forces. Okay. Fg, in all of the past papers I have seen, I don't know what's coming this year, guys, but in all the past papers I have seen, Fg, the gravitational force, is the only conservative force that you guys deal with at grade 12 level. Okay, we also have the force of an elastic spring. We also have the electrostatic force, but I've never seen them ask that in a work energy power question. So keep it somewhere at the back of your minds. For now, I want you guys to remember your only conservative force that you're going to deal with is Fg. Now, what is a conservative force? A conservative force, according to your exam guidelines, is a force for which the work done, keyword work done, if you leave that out you lose marks. A lot of learners skip the work done, okay? It's the force for which the work done in moving an object between 2 points is independent of the path taken. That's important. In other words, when the gravitational force does work, that work is only dependent on where it starts and where it ends. It doesn't care about anything else. So in this case, looking at Fg, Fg being a conservative force does one thing. It operates that way, and because the object is moving up, it does negative work. And we only care about the height where it starts, which is going to be 0, and the final place where it ends. And that is why for Fg we can use this. It's because it is a conservative force. Are we okay-ish? Okay, it's going to take time. You guys are going to have to think about this over and over again. If any of you are planning on doing BSc Physics, you're going to deal with this a lot, and you need to clear this out before you get to BSc Physics. Okay, if any of you are planning on studying BSc Chemistry, you're going to do Physics. Okay, my engineers, you're going to do Physics, so you can't neglect this. All right. Okay, but the reason, again, guys, the reason why we can use this for Fg is because Fg is a conservative force. It only depends on where we start, which is on the ground, and where we end, which is in the sky. In the sky, yeah, okay. And because it's working down and the displacement is there, we have a 180 degree angle. Are there any questions? Are we okay-ish? All right, okay. So for the force, if we look at this force F over there, if we look at friction, if we look at the normal force, guys, all of those other forces that you deal with, they are classified as non-conservative forces. Non-conservative forces are forces for which the work done is path dependent. So that means you must use the actual path taken. If you use any other path, any other displacement, you're going to miss out on something. Okay, now since we are here, let's just quickly discuss this. What do conservative and non-conservative forces, or maybe say this way, conservation, if we speak about conserving water, what does it mean? We're trying to save water, okay? Conserving the environment, we're trying to save it. I hope I'm using the right term, okay? But anyway, we're trying to save something. Here we're using exactly the same words, conservative and non-conservative. What does a conservative force save? What type of energy? Mechanical energy. A conservative force is a force which saves mechanical energy. Okay, we only have 15 minutes left, but it's okay. Here is my bottle of water, okay? It's currently on my little box at the moment. Taking this as our 0 position, the height is 0, and the object has, well, no mechanical energy, okay? So if we move it up, I am creating or changing or giving it, by my applied force, potential energy. So now it's at a stop, it's somewhere in the sky, and it has gravitational potential energy. If I let go of this, what gravity is going to do is, gravity is going to take this potential energy and it's going to convert it into a different kind of energy. What type of energy will gravity change this potential energy into? Kinetic energy. And again, I move it up in the opposite direction to gravitational force, kinetic into gravitation, potential energy. Okay, so what we are seeing is gravitational force creates this loop of gravitational potential energy to kinetic energy and vice versa. And as a result, when we only have the gravitational force acting on a body, we speak of an isolated system, and we can use the principle of conservation of mechanical energy. When you only have conservative forces acting on the body, then mechanical energy is conserved. So here at the top right hand corner, you may only use this when the only force acting on the object is Fg. Another word that we use for this is objects in free fall, okay? But you may also find when you have a pendulum that is swinging in space, because the normal force is not doing any work, that is also an isolated system, and you can use the principle of conservation of mechanical energy, okay? So, from this, coming back to the left-hand side, back to the start, I spoke about how we define work. And most of the time, you will not just be asked to calculate work. You might be asked to calculate the net work. Remember, there are 2 ways in which you can calculate net work, or 3 actually. You can first calculate the net force. When you calculate net force, you must think of Newton's laws, and direction is important. You're then going to only plug the magnitude in, and you need to draw a new free body diagram for yourself. The free body diagram will be the net force and the displacement. Okay, We're looking at the angle now between the net force and the displacement. Whatever the angle is there, it is the angle between this and that. Okay. The other way of calculating the net work, is to say we have a body and there are different forces acting on that body. We calculate the work done by each force and then we add it all together. Okay. Lastly, we can say, and this is not often used, but we can say the net work is equal to the sum of the conservative forces and the non-conservative forces. I've included this because some of you actually study. What I mean by study, guys, is you sit in a corner alone by yourself and you read through your textbook and you try on your own to comprehend the material. And I find that learners who normally do that understand the work better and a lot longer. So I know we have YouTube and you can make use of YouTube, which is good, but please take time to digest the content on your own. Okay, so over here, this formula, if you see it in your textbook, the conservative forces are just your Fg. The non-conservative forces is everything else. So it's just the sum of the work done by all of the forces. Is that okay, guys? All right. There's something I wanted to point out. Yes, over here. If I were to ask you in this case to calculate the work done by friction, you would tell me friction is in the opposite direction to the displacement. And when you calculate the work done by friction, you would say friction change in x cos 180. And if you know your, what are they called, identities or something like that, cos 180 is equal to -1, giving you a negative answer measured in joules. That negative is not direction. Okay, so you leave your answer alone with its negative. Don't go from there and try to interpret it and tell me it's towards the left. You're going to lose a mark. The negative is not direction as it is in Newton's laws. In this case, the direction refers to positive and, sorry, not direction, the negative refers to positive and negative work. We say positive work is when energy is gained. For example, my bottle, I apply a force, and what does this force do? It gives the bottle energy, okay? On the other hand, negative work is when energy is lost. If I push the box and you see it slows down, it's slowing down because friction force takes that mechanical energy and converts it into heat. Guys, you get different types of energy. You get light, you get sound, you get electrical energy. Those types of energies are not mechanical energy. Mechanical energy is simply the sum of the kinetic energy and potential energy. Different types of energies, but kinetic and potential energy, that is your mechanical energy. So if you're getting negatives or positives, it means we are adding mechanical energy or we are taking mechanical energy out of the system. Are we okay? Are there any questions? Okay. Again, when it comes to your principle of conservation of mechanical energy, you guys know you can only use it if you need to go have a break, you can, okay? For this one over here, you can only use it if Fg is the only force acting on the body, or, you guys are disturbing me, okay? Or if you have a pendulum and this pendulum is moving in space, okay? So Fg in these two cases is the only force that is doing work. But then we have this one at the bottom. Oops. Okay, we have the work energy theorem. Now guys, this over here is a special case of the work energy theorem. It's the work energy theorem when the non-conservative forces is 0. That is what it is, or when the work done by the non-conservative forces is 0. You know that the work energy theorem states that the net work is equal to the change in kinetic energy. Change is always final minus initial. So if you want to expand this, it's half mv final squared minus half mv initial squared. Okay. In this case over here, a lot of learners tend to confuse kinetic energy with momentum. I'm not too sure why, but remember momentum is P equals mv. They are different because of the half and the squares, so please be very careful, okay? If we look at the work done by non-conservative forces, there we say it's equal to the sum of the change in kinetic energy plus the sum of the change in potential energy, and you can expand it like that. So when this side is equal to 0, we end up with that formula. That is where that formula comes from. But they are all related. This one right at the top and these two all fall into each other. This is a special case of the work energy theorem in general. Okay, last thing and then I'm almost done talking. If we look at power, power is also a scalar quantity. It's measured in watts. Okay. All of you seem to be familiar with this formula, but there's another formula on your formula sheet for power, guys. If we expand this, we get work is equal to the force change in x. I'm going to assume theta is 0, so we have 1, divided by change in time. But what is change in x divided by change in time? Velocity or speed. So this formula, another form of it is this one. Please make sure that you see this formula and that you know how to use it, because year after year after year we ask you to calculate power and you are so familiar with this formula that you forget that there's another one and you leave the question blank. It always happens. Make sure you know your formula sheet. Okay. We have 5 minutes left, so just very quickly I'm going to run through these multiple choice questions with you. 1.5 says the mechanical energy of a moving object remains constant if. Okay. Mechanical energy remaining constant means mechanical energy is conserved. When mechanical energy is conserved, it means that the work done by the non-conservative forces is 0. And by the way, guys, in a test or exam, if you get an answer equal to 0, do not just write down 0 or you're not going to get your mark. You must still write down the SI unit. It seems silly, but they actually take away a mark if you don't write that. Okay, so over here, mechanical energy will remain constant if the non-conservative forces is 0. So, what type of force is a conservative force? Gravitational force. That's the only one we have seen in past papers. So we therefore know that Fg is the only force doing work on this body. Alright? And as a result, in this case, mechanical energy will remain constant if there is only gravitational force acting on the object. 1.6. Now I don't really like this question because it makes us assume a little bit. So I would say that there are two answers. They say two boxes X and Y have the same mass. Box X is lifted through a vertical height by H by a force of magnitude F. The box Y, is pulled up the slope by a force of the same magnitude to reach the same vertical height. So this question assumes that the hypotenuse over here is longer than this side. If you didn't make that assumption, if you assumed that it's a equilateral triangle, then your answer would be different. Okay, but you can sort of see that this is longer than that side. In this case, remember we said gravitational force is a conservative force. Conservative forces are path independent. They only care about where we start and where we end. So since this box goes from the floor to height h and this block goes from the floor to height h, the work done by the gravitational forces is going to be, oh, I missed the question. The work done by the gravitational force is going to be the same. And if we talk about gravitational potential energy, gravitational potential energy is EP equals mgh. Since the heights are the same, we know either this one or that one is correct. Okay. Now that we are done with that, they speak about the amount of work done by F. Is F a conservative force? No, it's not. It's non-conservative, which means it's path dependent. So in this case, assuming that these distances are not the same, taking into account there might be friction so on here, in this case over here, or that it might do this, in this case we're going to say the work done over here is not the same as the work done there. In fact, in this case, because and only because we assume this is longer than the height, we're going to say this is the correct answer. But if you said these distances are the same, you're not 100% wrong for saying B, if I'm not mistaken. Okay, and then the very, very last one. Okay, using an inextensible rope of negligible mass, Ben pulled a box along a horizontal surface with a constant horizontal force and moves the box at a constant velocity. Newton's laws, what does constant velocity mean? F net is equal to 0. If F net is equal to 0, it means the work done by the net forces is also equal to 0. Okay, keywords. They say the box moves, blah, blah. They say a constant frictional force acts on the box. Which one of the following statements concerning the motion of the box from A to B is true? The work done on the box by the gravitational force is not 0. It is 0 because gravitational force acts perpendicular to displacement. The total work done on the box by the net force is not 0. That is not true because it's going to be 0. The work done on the box by the friction force is positive. That can't be true because if the box moves to the right, friction force is towards the left and theta is 180. And we're going to hope that the last one is correct. They say the magnitude of the work done on the box by FA is equal to the magnitude of the work done by FK. This over here is correct, making D the correct answer. Okay, guys, before you leave, I'm going to ask you guys to do a little bit of work. Yeah, okay, I wouldn't be a physical science teacher if I didn't give you work to do by yourself. Not all of this, okay. You're just going to go, please, for me, to the Gauteng paper and the Western Cape paper. For the Western Cape paper, you guys are going to please try question number, what did we say? Question number 5. Western Cape paper, you are just going to try for me question number 5. And then for the Gauteng paper, you're going to please do question number 4. Western Cape number 5, Gauteng paper question number 4. Okay, guys, I'm going to leave you with a quote now. There's a quote that says, success is not to be pursued. It's to be attracted by the person you become. If any of you have seen it before, you'll know who I'm talking about here. It's a quote by Jim Rohn. I'm going to say it again. Success is not to be pursued. It's to be attracted by the person you become.